Good morning friends, I welcome you all for another lecture on the course Microprocessors and Microcontrollers. From last few classes we are discussing different concepts in 8051 microcontroller. In this class I am going to discuss about another important concept in 8051 which is timer slash counter operation in 8051 microcontroller. Right. So we know that 8051 microcontroller have two 16-bit timer slash counters. I repeat, 8051 has two 16-bit timer slash counters. That means the circuit can be act as a timer as well as counter. For better understanding, we can say like this: in 8051 there are two internal timer slash event counters. Internal timer, interval timer slash event counter. That means a timer is used to measure the time between two events or two operations. That's why it is called interval timer. Or it may also use it to find how much time an event can took place. These are two things that will be done by a timer. Event counter in the sense, it will count external things, external events, which are done external to your controller. So these are two things are done by a same circuit. That's why it is called timer slash counter. There are two such type of things are present in our 8051. And next important thing is, these two timer slash counter circuits always do up counting. They never do down counting. So that these are called up counters. These are always doing up counting. They never do down counting. So please remember these are few points in your mind. Then I start my concept. So 8051 has a two 16-bit up timer slash counter registers. Those are T0 and T1. These can be implemented with the two 8-bit registers. Those are called TLX and THX, where X is 0 or 1. So that means here it may be TL0 or TL1. So TL0 means timer 0 lower bytes. TL1 means timer 1 lower byte. And similarly here THX means TH0 or TH1. TH0 means timer 0 higher byte. TH1 means timer 1 higher byte. That means if I go and take a T0, it is a combination of two 8-bit registers. One is this 0 to 7 and 8 to 15. 0 to 7 we consider as TL0 and 8 to 15 we consider as TH0. In a similar way, T1, it is again combination of two 8-bit registers. 0 to 7 we consider as TL1 and 8 to 15 we consider as TH1. So that is the meaning of this. And next is to control the operation of these timers. 8051 has two special function registers. One is a TCON, means a timer control register, and second one is a TMOD, timer mode selection register. So later we can go and see the internal structure of TCON as well as TMOD. Just now I told you that T0 can be formed by the combination of TH0, TL0 like this, and similarly T1 can be combination of TH1 and TL1 like this. So in this case, totally you identify 6 different registers. Those are TH0, TL0, TH1, TL1, TMOD and TCON. So out of these 6 registers, these are first of 5 registers, that is TL0, TH0, TL1, TH1 and TMOD. These are byte addressable registers. But coming to TCON register, that was a timer control register, which is a bit addressable register. That means we can go and give an address for each and every bit of TCON register. That's why it is called bit addressable register. Coming to next, the timers T0 and T1 main purpose is to measure time between two events and count external events. Once it measures time, that incident your T0 and T1 act as a timers. Those we can call as interval timers. And once they are used to count external events, the time your T0 and T1 is act as event counters. Event counters. So see here guys, T0 and T1 is act as a timers for internal operation of 8051 and they accept the input clock pulse from internal oscillator circuit. One thing friends, T0 and T1 their function is counting of clock pulses. Either it is act as a timer or it is act as a counter. In order to distinguish your circuit is a timer or a counter, from where it will get an input clock pulse. So further it give a clarity this point, that is, if I want to use a T0 or a T1 act as a timer, the receiving the clock signals from internal oscillator circuit. We know that our 8051 has inbuilt oscillator circuit. It will generate a clock signals. Those are counted by my T0 or T1. The time those two I can call as a timers. But they are not receiving a clock pulse from an internal oscillator circuit. They are receiving the clock signals from an external devices with the help of port 3 signals T0 and T1. That the time T0 and T1 is act as event counters. That I was mentioned here. T0 and T1 act as event counters for external operation of 8051 and they accept the input clock pulse from external through T0 and T1 port 3 signals. So that's the meaning of this. And now it is very important circuit friends. You have listen carefully about this because it is the heart for the internal timer / counter operation of 8051. So this what this is, it is the control logic circuitry for timer / counter circuit. So see here guys, so this stage you may have either T0 or T1. Don't think this is T0, it is two timer stages. Two timer stages, that means there you may found either T0 or T1. So see here guys, there are two switches present in this entire control logic. The first switch, connection of this switch, it decides where we are getting the clock pulse for timer stages. Either it will get the clock signals from an internal oscillator circuit or it will get the clock signal from external devices through T0 and T1. See here guys, this is decided by a signal called or a bit called C/T bar, which is present in TMOD register. So what is a C/T bar? C/T bar means counter / timer bar. That means your T0 or T1 is act as a timer or a counter that is decided by the bit called C/T bar, which is present internal to a TMOD register. So here the bit controls this particular switch. So see here guys, this switch is connected to this particular line. This line was getting from internal oscillator circuit. That means this internal oscillator circuit produces a clock pulse. Those are passes through, divide by 12D circuit, and then here we are getting a clock pulse. Listen friends, here what this 12D circuit divide by 12D circuit. You remember in 8051 microcontroller, each and every machine cycle has 12 clock pulses. I repeat, in 8051 microcontroller, a machine cycle has total 12 clock pulses. That's why the oscillator generated clock signal passes through this divider circuit, then it appears here. Once this switch is connected to this, no doubt here the timer stages will act as interval timers. If this switch is connected to this end, guys, see here, it is connected to this. That means the time C/T bar equal to 1, it is equal to 1 that related to counter. Once your T0 or T1 is act as a counter, they are counting the clock pulses which are received from the external devices through port 3 signals T0 and T1. So these are the port signals. With the help of T1 and T0, they are receiving the clock signals. So that time your T0 and T1 is act as counter. If it is act as a timer, it receives the clock signal from an oscillator. Those are act as a counters, they are receiving clock signals from external devices with the help of port 3 signals T0 and T1. So this is one stage. Now the clock is received by the timer stages only when this switch was closed. This switch is now controlled by an AND gate. This AND gate have two inputs. One input is straight away from timer run bits from timer control register TCON, that is a TR1/TR0, and the second input is from an output of R gate. One thing you remember, friends, this switch is closed once AND gate output is 1. When an AND gate produces logic 1, both the inputs of AND gate is 1. So this bit must be 1 and this is must be 1. So here, if I want to start a counting of a clock pulses by either T0 or T1, the corresponding timer run bits present in timer control register TCON must be set to 1. So here that TR1 and TR0 called timer 1 run bit, timer 0 run bit. So that we always make this bit is 1. And now this switch is closing or open completely depends on the second input of AND gate. The second input of AND gate is purely depends on OR gate. When OR gate produces logic 1, except these two inputs are 0. Except these two inputs are 0, for remaining cases my OR gate produces logic 1. That means either this one, or this is 0 or this one, or this is 0, this is 1. For these three cases, OR gate will produces logic 1. So see here guys, for this OR gate, one input is INT 1 bar / 0 input pin. That means these INT 1 bar and INT 0 bar related to external inputs. That means these external interrupts are received by your controller only when it will identify logic 0 because these are act low signals. If this is 1, that means there is no external interrupts. If there is no external interrupts, irrespective of this gate input, the OR gate will produce logic 1. That is a required signal to produce AND gate logic 1 to close this switch. Listen carefully friends, once there is no external interrupts, the time this INT 1 bar and INT 0 bar becomes 1. That is a required signal to produce logic 1 at output of OR gate irrespective of gate bit. And this is the signal which is required for me to produce logic 1 at the output of an AND gate to close this second switch. The second case, if you may receive any external interrupts, from the external devices by using INT 1 bar or INT 0 bar, the time this signal logic level is 0, no OR gate purely depends on gate input to produce logic 1. So here, what we do is, gate is act to high signal. So by making up this bit is 1, it passes through a NOT gate, its logic level is equal to 0. In order to turn on my OR gate produces logic 1 irrespective of this external interrupts, definitely I make the gate bit is equal to 0. When it's processed through a NOT gate, output becomes 1. Then this is a required signal for an OR gate to produce logic 1 irrespective of external interrupts. So it means the OR gate will produce logic 1 for two cases. Number one is there is no external interrupts. That is one case to produce logic 1 at output of OR gate. And second time where an OR gate will produce logic 1 is if you may have any external interrupts. Then with the help of a gate signal, with the help of a gate bit which was present in TMOD register, OR gate will produce logic 0. By making of this gate bit is equal to 0, it passes through a NOT gate, then it will produce logic 1 at output of OR gate. So this is the control logic circuitry of timer/counters in our 8051. I hope you understand this. Then, so coming to the important thing, the timer control register TCON. We know that the timer control register TCON is a bit addressable register. That means each and every bit have an individual address. And here important thing is, out of 8 bits, for our timers operation, only these 4 bits are helpful to us. Only these 4 bits are related to timer operation, and the next 4 bits, that is the least significant nibble, it is not related to timers, these are related to interrupts. These are related to interrupts. Why it is a timer control register is, with the help of these most significant nibble bits of timer control register, I can control my timer's operation. How I can control my timer's operation? The timer T1 starts its counting only when its a timer run bit must be set to 1. If I make this a timer 1 run bit is equal to 0, then my timer 1 starts its counting of input clock pulses. Similarly, my timer 0 starts a counting of input clock pulses only when this a TR0 set to 1. My timer 0 stops its counting of input clock pulses when this timer run bit TR0 becomes 0. That's why with the help of these TR1 and TR0, I can control the operation of my timers T1 and T0. These 2 bits are present in my timer control register TCON. And one more thing is, it has a flag bits also. That means once my timer content rolls off its value from maximum to minimum, that indicates my timer finishes its job. My timer finishes its job. That time these flags are very helpful for me. I already told you the timers which are present in 805, always those are up counters. Those are always up counters. Once they reaches to maximum value, the time it will receive one more clock pulse. What happens is, the content of the corresponding timer or counter rolls off its value from maximum to minimum. That indicates that the corresponding timer finishes its job. That condition we identified with the help of a bits called TF1 and TF0. These are 2 we can consider as a status flags. These we are calling as status flags. So TF0 is called timer 0 overflow flag, and TF1 we can call as timer 1 overflow flag. These 2 we are considered as an interrupts of our 8051 also. So see here guys, TCON is an 8-bit control register and contains a timer and interrupt flags. So that's what I am saying. Most significant nibble is for timers operation and least significant nibble is for interrupts case. Its internal address is 88H. And coming to TF1, that is the most significant bit. I already told you that is a timer 1 overflow flag. When it is set to 1, it is set to 1, the timer 1 overflow occurred. The timer 1 overflow occurred. When it was occurred, that is timer 1 content is rolls off from maximum to minimum. What is the meaning of this? The maximum value present in timer 1. Timer 1 is your 16-bit register. Its a maximum value is 4FH. That means those 16 bits are ones. If you convert into hexadecimal, that you are getting 4FH to the minimum in the sense of 40H. That means those 16 bits becomes 0. So once timer 1 content rolls off its a value from maximum to minimum, we can say that timer 1 overflows. So that time your TF1 becomes 1. Your TF1 is equal to 0. That means timer 1 overflow not occurred. Timer 1 overflow not occurred. The same thing you can apply for the next TF0 case also. So TF0 we can consider as timer 0 overflow flag. If this bit is set to 1, that means timer 0 overflow occurred. That means a timer 0 content is rolls off from maximum to minimum. That means FFH2 0000H. Once it was happened, then automatically this flag becomes 1 and it is equal to 0. That indicates timer 0 overflow not occurred, like a previous case. And next TR1, that is nothing but timer 1 run bit. It is a control bit, and TF1 is a flag. So run bit, by making of this bit is 1, timer 1 starts its counting, it is 0, timer 1 stops its counting. Similarly, TR0, It is for timer 0 run bit, timer 0 run control bit. By making of this bit 1, timer 0 starts its counting. If it is 0, timer 0 stop its count. Right. Next up, if you go and consider the least significant nibble of your timer control register, those bits are helpful for our interrupts. In that, the first bit is IE1, that means external interrupt 1 edge flag. So if this bit is set to 1, that means external interrupt 1 was occurred. That means once this bit is set to 1, that means your controller can receive an interrupt by using a signal called INT1 bar. I repeat, if this bit is set to 1, that means your controller receives an interrupt from an external device by using INT1 bar. Similar type of bit you may found here, that is INT, you may get in the next slide. So, if it is 0, that indicates external interrupt process. That means we are not getting any interrupts over the particular signal. That is. Next IT1, external interrupt 1, triggering select bit. By programming of this, we have select the triggering notation. That means at what triggering mode we are using to go and receive an interrupt from an external device by using INT1 bar. Either you can go and use that is a rising edge triggering, or we are using falling edge triggering. If this bit is set to 1, then your controller identifies the interrupt on INT1 bar only at the falling edges of the clock pulse. Falling edges of the clock pulse. Similarly, if it is set to 0, your controller can identify interrupts over that INT1 bar only at lower level of that. Why? Because falling edge we are considering, lower level we are considering, because falling edge indicates from logic level 1 to 0 and low level indicates logic 0. Why? Because this signal is active low signal. This signal is active low signal. So by using IE1, we identify the receiving of interrupt or not. By using IT1, we can define the triggering notation of an interrupt which is received by the controller with the help of INT1 bar signal. The same type of signals you may found for another signal, that is INT0 bar. See here guys. So IE0, it is similar to IE1. So with the help of this IE0, I identify that any interrupt I was received from an external devices by using a signal called INT0 bar. INT0 bar. And similarly, the triggering notation of that I was defined with the help of IT0 bar. That means lower level of timer control register is helpful for me to go and define the interrupt related operations. Fine. And next one is timer mode selection register, TMOD. So again, it is an 8-bit register and it is a byte addressable register. That is the first thing. And second thing, if you identify this, you split this TMOD register into two halves, like a lower nibble and upper nibble. The lower nibble is completely dedicated to timer 0 operation and upper nibble is dedicated to timer 1 operation. The bits are same: gate bit, C/T bar and C/T bar, M1 and M1, M0 and M0. So bar here I can do, we can also call prime. So both indicate same meaning, nothing different. So see here guys, TMOD is an 8-bit register used to set timer mode of operation for timer 0 and timer 1. Its internal address is 89H. Its lower 4 bits are used for timer 0, just now what I am saying, and upper 4 bits are used for timer 1. So coming to bits case, gate bit. This bit just now we are observing in the control logic circuit. So by making of gate bit is equal to 0, we can enable timer/counter operation when TR0 and TR1 is set. If it is 1, enable timer/counter operation only when INT0 bar or INT1 pin is active high. So and TR0 and TR1 is select. So already we discussed this when I am talking about control logic circuit. Next C/T prime or C/T bar, that means counter/timer bar. So with the help of this, I can define my T0 is act as a counter or it is act as a timer. So if this bit is set to 1, then my corresponding timer is act as a counter itself. If it is 0, my selected one is act as timer itself. And now important one is M1 and M0. So M1 and M0 we call as timer slash counter mode selection bits. So see here friends, M1 and M0, my mode of operation and what that operation is. If both are set to 0, 0, then it is called mode 0 operation. Mode 0 operation we can also call 13-bit timer slash counter operation. If it is 0, 1, called mode 1, it is called 16-bit timer slash counter operation. And next is 1, 0, mode 2 operation. It is 8-bit timer slash counter. It is also called auto reload mode of operation. And next 1, 1, mode 3 operation. It is a 2 independent 8-bit timer slash counter operation of timer 0. Or you can also call as split timer operation of T0. So like this we are going to select the mode of operation of 8051. So I hope you understand the timers which are present in 8051. So what are the registers that are related to this timer slash counter operation? The control logic circuitry and its working, and the internal register TCON and its bits and their functions, and as well as a TMOD register structure, its bit functions. In the next class, I am going to discuss about the modes of operation of 8051. Thank you for patience.